Alright, welcome back. In this video, we're going to go over Intro to Alkenes. I made a lifetime total of $60.64. Alright, so this is going to be a very basic overview of the reactions of the alkenes. I'm not going to go in depth, but I'm just going over the overview, and the in-depth stuff will be later. Okay, what are alkenes? It's basically a carbon-carbon double bond. That's it. So this right here is an alkene. This is a carbon, this is the carbon, and this is the double bond. It's very common in compounds with unique smells. It's also very common in our body. Now, here is the thing that really amazes people, because they don't really think about this. But what the reactions we are doing with alkenes, they are called addition reactions, because we're going to be adding something. We're going to be adding functional groups to our molecule. Now, what's really cool about this is that we were studying about elimination reactions this entire time, right? Where we use a base to eliminate a halogen and hydrogen, and we replace it with a double bond. So that was our normal elimination reaction, right? And you would run these elimination reactions under high temperatures. But we can actually do the reverse. What happens if you want to break that double bond and add a halogen or hydrogen to it? And we can do that. That's called an addition reaction. And we do that at low temperatures. So to basically get the addition reaction pathway, we would lower the temperature. If you wanted to favor the elimination pathway, raise the temperature. So we were talking about elimination reactions, and we talked about Zaitsev and Hoffman. Basically, where would the double bond go? When we talk about addition reactions, there's something called Markovnikov and anti-Markovnikov. And that's basically saying, where does the hydrogen go? Instead of the double bond, because you got rid of the double bond, right? We're going from a double bond to a basic molecule, an alkane. But the question is, where does the hydrogen go? To the more substituted carbon or less substituted carbon? And that's Markovnikov and anti-Markovnikov. So going this way, going towards elimination reactions, we have Zaitsev and Hoffman. And going towards addition reactions, we have Markovnikov. I want to spell this wrong. Markovnikov and anti-Markovnikov. Whatever, anti. Okay, so you get the point. But we're going to go, much more in depth in future videos. But just an overview. So why are we learning this? Bunch of odors are made up of alkenes. This is the smell. This is responsible for the smell of garlic. This is perfumes. This is the smell of oranges. But it's also in our body, our human body. Cholesterol has alkenes. Testosterone, estrogen, steroid hormones, almost actually a lot of hormones, have alkenes. But also, the reason why we're learning this is because, say you're in a lab, you're a chemist, or you're in the pharmaceutical company trying to make a drug, and you have a molecule, and you need to add stuff to it. Well, what you can do is you can do an elimination reaction first, if there's an halogen there. Then we can add, we use a base to get rid of the halogen and the hydrogen, so we have a double bond, we form a double bond, and then we can use an addition reaction to add whatever functional group that we need to add. That's why it's super useful, so you can just build stuff from this. Okay, here are all the types of alkene reactions that we're going to be learning about. The first one is called hydrohalogenation. This is going to be the most frequent one you'll see, especially on exams. You will see hydrohalogenation a lot. And what we're doing is we're adding a hydrogen and a halogen to our molecule. So we sacrifice the double bond to get a hydrogen and a halogen. The halogen can be chlorine, bromine, and iodine, not fluorine. Fluorine cannot do it. It's not possible. It's a trick question. If anytime you see fluorine, it will not do anything. There's also hydration reactions where we add a hydrogen and an OH group. There's hydrogenation, where we are generating hydrogens. So two hydrogens we're generating. Halogenation is we add two halogens. Isn't that cool? So you could have chlorine, bromine, iodine, whatever you want. There's halohydrin formation, which is an OH and a halogen. And then there's the addition of two OHs, which is called dihydroxylation. So this is just basically a little cheat sheet that you can take a picture of. That's the reason I did it. Have it as a reference sheet to help you out when I make the future videos on alkenes. But until next time, later.